Hi, my name is Marcos, and today we're going to be looking at a critical piece of AI engineering that often gets overlooked until it's time to move to production. Inference optimization from chapter 9 of AI engineering book by Chip Huyen. When we talk about software architecture, we're always balancing key drivers like scalability, performance, and costs. In a world of large language models, these trade offs manifest in how we serve these models to the users. Now, before we look at how to optimize, we have to know what we are measuring. So in the inference, there are basically two primary metrics that we define for the user experience. The first one is time for the first token, and this is basically the responsiveness of the system, how long the user should wait before the first word appears. Then we have the time per output token, and this is our streaming speed, how fast we generate each token and have the final response. And here is important that one architecture decision is to, if you're streaming these output tokens, or if you're just showing at the final. So this could harm the user experience if you go on the second way, but it will be more easy to, if you don't have like the tooling for streaming the each token at a time. Next, moving to the levels of optimization. So when we are looking in this part of optimization specifically, for large language models, we have basically three ways to optimize. The first and more common is using for OpenAI and Anthropic when you are using the APIs, is service level. But if you're hosting your own models, you have the opportunity or the challenge to look at model level or hardware level optimization. Going to the model level optimization, basically we have three main strategies. The first one is pruning, which it involves like removing nodes of the network that are not contributing much to the final output. The second one is distillation, in which we train a smaller student model to mimic a larger teacher model. And finally, we have quantization, which involves, this is more impactful, and it involves reducing the precision of the weights, so we don't harm actually so much the uh, the the final result, but we have a low precision in our training process. And the trade-off here is that you are trading a bit of accuracy to gain speed, and reduce the memory footprint, for example. Talking about a very interesting strategy used for all the transformer based architecture. So one of the biggest bottlenecks in the transformer are the attention mechanism, because these models are basically autoregressive, meaning that to generate the next token, we need to take a look on all the previous one. So to solve this, we can use a strategy called KV caching, in which we store the key and value tensors from previous token, so we don't need to recompute every time. And this is critical for long-term workloads. And without this KV caching, your latency could be harmed exponentially if you have like generate a large response, for example. Talking about service level optimization, uh, when a model is too big for one chip, we need to use parallelism in a way that we can use tensor parallelism, where you split the matrix multiplication across different devices, and this is great for reducing the latency. Then we have pipeline parallelism, and in which different stages of the model run in different devices, and almost like assembly line. And as architects, we have to choose: do we want a replica parallelism to handle multiple users, or do we have tensor parallelism to have a single user with faster requests? And basically, to summarize all the talking about in this chapter, basically we have 3 points. Basically, hardware matters. Your model, your model efficiency is fundamentally capped by the AI accelerators it runs on it. That's why we have like the price of the RAM memory like increasing because the companies are prioritizing creating these accelerator chips. Quantization is your friend, so you can use it to gain more speed by reducing the um, the precision of the overall training. Another point that I didn't mention that it is this prompt caching, so we can have parts of your prompt cached during the inference, so we don't have to take a look on the all context when generating the next word, for example. So we have this segmentation caching that is pretty much useful for optimizing the overall inference processes. And yeah, basically that's it for this chapter. In the next time, we will talk about the last chapter of this amazing book. And yeah, thanks so much for listening, and I'll see you in the next lesson. Bye bye.